Welcome to all. Today, question 24. Something important is there. I will tell. Somewhat special type of question. What all I tell, you listen correctly. If confusion is there, again go for. Same thing I can't tell second time. See, some inclined loads are given here. Frame is already known for you. See, inclined frames loads given. Right here. Usually what we do, when inclined forces are given, we are going for resolution first. Replace them by horizontal and vertical component, our usual procedure. Then start solving. We have done already so many questions. But if you observe here, something special is there. See, these 10 kilonewton, 25 kilonewton and 16 kilonewton, they are inclined no doubt, but they are perpendicular to member. See, in the roof truss all, this is called a principal rafter. Wind load sometimes will be taken perpendicular. So these are, don't worry too much about steel structures now. These three loads are perpendicular to member. If they are perpendicular to member, one advantage is there. You can solve the question without resolving by taking the forces as it is. No resolution not required. You can save the time. Anyway, does not matter. Some will tell, no sir, we will go for resolution. Okay. But one question I will solve. So, but one condition is there. See, these three inclined forces are perpendicular to member. Okay. But other inclined load should not be there. There should not be a random inclined load here. Then mix-up will come. No. Then you go for resolution. See, earlier class also, I have given one question, I have given on this member, load perpendicular. But somewhere there, random inclined. No. Those questions solve. You go for usual resolution. But if all the inclined loads are perpendicular to a member, you need not go for resolution. I am telling principal point of view. Therefore, I will solve this question. I will solve 2 times now. Option 1. See, special type as a special solution. Write what all I dictate now. If you want to understand correctly what all I dictate, you should write. But one thing, one note right there. Those people getting confusion, someone will tell, after listening to all this, they will make the face like this. Sir, usually we don't do this way, sir. We resolve. This is slightly confusing me. Okay, no problem. Those getting confusion, you leave this one. Go for option 2. That is our usual procedure. What is usual procedure? Resolution. Then this special is not there. So what you do? See the second of this class. After option 1 is over, I will go to option 2. You study that one. Don't study this one. That's all. Those who are serious, study both. Okay. Now, see now. Now one note you have to write now. See here. When we take moment about A, 10 into 0, 25 is perpendicular to the member. So 25 into A to D and 16 into A to C. Other loads are no problem. So for finding support reactions, we need this what? We need this AD distance and DC distance. And also, and also later we require this angle theta. Refer the sketch here. This angle theta you require. Okay, go for it. First do one thing. A, C, G. That side not required. Okay, leave it. Why unnecessary? Okay. Now it is happy, I think. Okay, see this side. First you calculate this AC length. How? Use the triangle AGC. AGC. Right angle triangle. Cos 40 equal to AG divided by AC. AG is 6 meter. You can see here. So AC you will get 7.8324 meter A to C. See, these are all equal. So when these two are equal, these also equal. So once you get AC 7.8324, AD equal to DC equal to 7.8324 divided by 2. So this one and this one are 3.9162. See here, I written right later, not now, later. 3.9162, 3 point, with this so far, we never wrote like this. 3.9162, 3.9162 over. Then, later, to find the angle theta, you require this height. See, tan theta equal to CG by FG. FG is known. To get CG, use the same triangle, AFG. Instead of cos 40, go for tan 40. Tan 40 equal to CG divided by AG. AG is 6 meter, CG will come 6 into tan 40, 5.0346 meter. This height will come. Then your tan theta equal to CG divided by FG, get the value of theta. Okay, over. Draw a neat sketch here. See, these loads maintain as it is because special. And one more thing, time being, that's all. Don't see other things. Okay. Take moment about A. One thing I not told. Calculation of support reactions, somewhere right there in the beginning only. VA, HA, RB. If anybody will ask, sir, what is this, sir? Means don't continue my class. A is hinged support. This all 1,000 times over. You write the statement. When you find support reaction, this statement you write. Okay, then see here. Take moment about A. Minus VB, anti-clockwise positive. Minus VB into 12, then 10 into 0. See, 25 into perpendicular. 3.9162 plus 16 into this distance is 3.9162 plus 3.9162, or directly, see here, 7.8324. Then plus 30 into 9, 14 into 9, 12 into 6, 8 into 3 equal to 0. You get the value of VB. Sigma V0, upward positive, plus VA plus VB, minus, then now you require vertical component. So, see, this member is making 40 degree with horizontal. Since this line is making 40 degree with horizontal, its perpendicular will make 50 with horizontal. Here, see, if it is 40, same 40 here. This is 50. After all, high school mathematics, this line makes 40 degree with horizontal, means the perpendicular will make 50 degree with horizontal. Okay, now, so plus VA plus VB, minus 10 sin 50, minus 25 sin 50, minus 16 sin 50, minus 30, minus 14, minus 12, minus 8 equal to 0. You substitute for VB, you get the value of VA. Some space is not there, come here. Sigma H equal to 0, right side positive, plus HA plus 10 cos 50 plus 25 cos 50 plus 16 cos 50 equal to 0. HA will come minus 32.782. Okay, now I rub the board. Question I am not, see, this question I am not removing. This question I am not removing. Why? I want it for option 2. I will rub the board because now I am giving answer for you. I will rub the complete board, and what I will do? Draw a neat sketch here, star sketch, where VB and VA I will enter. HA right side I have taken, negative sign came, I will enter 32.782 left side. These three forces I will maintain as it is. At the joint you will resolve it later. And this angle I will mark how much? 59.210 degrees. So I will prepare it and start. Option 2 is still pending. Anybody any confusion about it? Option 2 is there. Okay. Now, actually, right, now start enjoying. What I told, I entered everything. See, inclined forces as it is, but remember, normal. This is perpendicular member with horizontal 50 degrees. This is 40 degrees. Okay, start. What you will do? I will start from joint A. This all explained. I start from joint A. See there. Joint A. 43.466. 37.782. Then 110 this way. This way. How much angle? With now you want angle with horizontal. 50 degrees. One unknown force here. One unknown force here. I will assume like that. Why I assume you should not ask. I told 1,000 times. If you got difficulty, you assume whatever you want. Sigma V0, you get PAC sigma H0, you get PAF. Now if anybody will tell, sir, how to get it means, stop at continuing my class. Question number 20, already 23, 24. Most probably I told more than 200 times this calculation. So, okay, now I cannot do anything. Okay, start. This is somewhat important portion I covered. Okay, now start. Come here. Enter the forces. How much here? See, we assumed force, which one? PAC like this. Correct, positive. Take a photo, all you know it. This is at your star sketch. See, this is your star sketch. How much answer? 55.704. 704 kilonewton. This force is, you took this way. Sorry. What is this one? This is coming to the joint. See, I can make out immediately. See, because that member is a compression member. I know it. See, by mistake I wrote it. I can make out this way. Here. Whatever you assumed is correct. Enter here. 69.026 kilonewton. Okay, this is also over. Now, one more joint I will cover and stop. Consider equilibrium of joint D. Okay, joint D. See here. Joint D. See here. Joint D is here. One force inclined coming here. Oh, now how much it is? 25 kilonewton, which is making 50 degree with horizontal. So these are the component. Okay, then one force coming this way. These are all known for you. Coming to the joint. That force is PDA. PDA. It is already known how much? 55.704. 55.704 kilonewton. The angle is 40 degrees for that one. Components are like this. Then one force continuing here. I will take like this. I know it. PDC. I will take acting to the joint. This also angle 40 degrees. This way and this way. One more force is vertically unknown. How much it is? PDF. I will take it as PDC is coming. This is 55. This is okay. I will take it as okay down. I don't down actually. This is 55. 50. Anyway, 1 minute. I'll take same way. We'll see later. Because why confusion? PDF. DF. Okay. Now, be careful now. Thousands of time told. One unknown inclined, other unknown vertical. Eliminate vertical first by sigma h equal to 0. When you make sigma h equal to 0, you will get the value of PDC. How means I can't tell. Sorry. I will not tell now. Minus P. See, somebody will ask, you is not explaining means I am not explaining. Don't continue the class. PDC will come. That is how much? 55.704. 704 into cos 40. That is right side. Then plus 25 into cos 50. Oh, sorry, wrong. Because I forgot to close the bracket. Usual problem in the calculator. 55.704 into cos 40. Equal I will put. Plus 25 into cos 50. The two component. Whatever answer divided by cos 40. Okay. 76.681 plus 76.681 will come. 681 kilonewton. You solve it. But homework for you. Next make sigma V0, take upward positive, whatever positive you take, no problem. Then you will get 76.681 minus 55.704, this calculator problem here, that into sin 40, that is a downward component, plus 25 into sin 50 over 32.635. You will get P, which one? That is joint here. I forgot to name my joint only. This is joint D. PDF. PDF will come plus 32.635. I think visible. I'll check the camera once. 635. Check the camera once. The camera moved there. See, when I come here, if I touch the, sometime I touch the camera, okay, no problem. Okay, what happened is, I checked the camera, then I wanted to pause. By chance, I closed it. So, I forgot one thing. Okay, enter the value here. We took force like this. See. How much answer? 76.681 kilonewton. And this force upward, I'm not going to the joint, 32.635. 32.635 kilonewton. This force over. Now do one thing. C joint will not go. See, A over D over. See where I am going. I'll just tell where I am going and then you solve. Now I need not explain to you. Okay, now do one thing. Come to the joint. I will tell you which joint. Now, see, after A, B, D, C, D over. Come to the joint F. Okay, I use red color now. Come to the joint F. See, first A, after A, D, already over. Come to the joint F. 32.635 vertical first set 32.635 plus 8 divided by sine 59.210. Slowly I am doing because I do not want mistake. 47.302. This force will come. See, this force will come. It will come 47.302 kilonewton and this force will come 47.302 into cos what, not 50, oh sorry, I cut it. 47.302 into cos of 59.210, that is this component. How much it is? 24, so it will come this way, minus 69.026. 44.812 will come. 812. Okay. Next, after F over now, come to G. Over within no time. Then, now do one thing. Better go to B. This G over now, go to B. 92.724 71.031 31 kilonewton. Okay. Now, which joint? Go to joint E. Better. E is best. Go there. Don't bother. You solve systematically. What is that load? 30. Okay. Not visible properly. 30 kilonewton. Now, lastly, go to joint H. H. 30 plus 14. 30 plus 14 is how much? 30 plus 14 is, I know why this calculator is not working. 44 divided by sine 59.210. Oh, 51.219. Oh, this problem is a calculator, heavy problem, my calculator. How much is 50? Something wrong. Down. No, something wrong. 71 this way. 44 this. I calculate 51.219. Okay. 51.219. I got it by vertical equilibrium. If I do horizontal equilibrium, 71.031 minus 44.812 divided by cos of 59.210. 51.239. 51.24 it is coming. It is 51, 1 meter. Check once again now. 30 plus 14 divided by sine of 59.210 is 51.219. Answer. If I do horizontal equilibrium, 71.031 minus 44.812, that answer divided by cos of 59.210. 51.219. Yes, perfectly tallying. I am not going to check here. If you want to check, see, I'll check it now. If you want to check, sigma v, just for fun, minus 16 sin 50, minus 16 into sin 50, minus 12, plus 76.681 into sin 40, plus 92.724 into sin 40 are gone, full gone. When I press cos or sin, I had to close the bracket. My old calculator was not that way. More than 30-40 years I used the calculator. See, problem. I hit the calculator too hard, I think. 1 minute, yes. See, this is problem for me because this calculator problem. Okay, I'll do one thing now. See, minus 16 sin 50, minus 16 into sin 50 equal to, okay, plus 76.681 into sin 40 equal to, plus 92.724 into sin 40 equal to, minus 51.219 into sin 59.210, again minus 47.302 into sin 59.210. So far coming plus 12. So far coming 12.0 something minus 12.003. Okay, done. Sigma h tallied. You take it over. This result we got by option 1. Now I will go for option 2. Make a note. People who find this concept difficult, oh, if the force is perpendicular, you need not resolve. You can, while taking moment, you take this distance. If you can find the, see, this distance is known for you. See, load into this distance. But people who feel confusion, go for option 2. Option 2, I will not explain much. Why? It is already over. See, now I will go to option 2. Question is still here. Just a minute. Okay, now option 2. See, option 2 now is, make a note here. This is for those who get confusion for option 1. I think majority will go to option 2 only. Option 1, if you can remember. So option 2 is nothing. That is our usual procedure. Class. Inclined forces we are resolving right here. So see, 10 kilonewton force, already told for you, is perpendicular to this member. This AC is making 40 degrees. When AC is making 40 degree here, that perpendicular with horizontal will make 50 degrees. This much you should know it. See, very simple. See here. First of all, I should not explain. This is your AC. AC. See. AC. This is 40 degrees. The perpendicular here. See. If this is 40, this is also 40 degrees. So, this is perpendicular. This will be 50 degrees. So, all these three forces will make 50 degree with horizontal. Therefore, resolve here. How much resolve? Now, if anybody will tell, sir, we don't know how to resolve, right now stop continuing my classes. See, 10 into cos 50 is 6.428. 6.428 kilonewton. 10 into sin 50 is 7.660. 660 kilonewton. So later, what I will do, this 10 kilonewton, I replace by these two forces. Which point? Through the point A. Okay, then through the point D, what I will do? 25 kilonewton. 25 into cos 60, cos 50. 25 into cos 50 is 16.070. 16.070 kilonewton. And 25 into sin 50 is 19.151 kilonewton. 151 kilonewton. So this 25 I replace by these two at D. And lastly, 16 at C I replace by 16 into cos 50 is 10.285 kilonewton. Another one is 16 into sin 50, 12.257 kilonewton. Okay, resolution over. Now make a note. When you take moment now, see, horizontal force into vertical distance required. Horizontal force into vertical. So you require DF and CG. See, we need this DF and CG for taking moment, sigma m0. Same as last time, see, this triangle. Consider the triangle ACG, ADF first. See, first you consider AFD. Okay, AFD. Tan 40 equal to DF divided by 3 meter. Get it? You get this height, 2.5173. And consider this triangle. Tan 40 equal to CG divided by 6 meter. You get CG. Lastly, you require one theta. This tan theta equal to CG divided by 3. Get the theta. I should have told fast all this. Okay, now what you do? Draw a neat sketch. You know what I am doing. Okay, now I'll do one thing now. Okay, I'll write the sketch and then explain. That is much better instead of wasting time. Okay. Now, this I wrote for my reference only. See, neat sketch right here. Calculation of support reactions. Usual statement you write this time. Let VA be the upward reaction, HA horizontal reaction, normal reaction VB, all you write here. Now one problem, see, at the hinged support here, there is one component and horizontal action. They will overlap. So write a little bigger hinge here, bigger hinge. This is that horizontal component. See what we got. This is horizontal reaction. This I told earlier. Go back to earlier class. I told. See what happens here. Horizontal reaction comes. Component also comes. See, it's component. They will merge. Or I write the component somewhere here. Show it a bigger hinge. Okay. Take moment about A. Minus VB. This height, how much? Full height is 5.0346. This partial height is 2.5173. This angle, this is 40 degree, not required now. See. Minus VB into 12. See. These two into 0. Plus 16.07 into this height, 19.151 into this distance, 12.85 into 2, this height, full height, 12.257 into this distance, 6. Then remaining, you know it, get sigma V0, VB will come. Sigma V0, you can do yourself only, get VA, sigma H0, get HA. Okay, now, last step. See, this is actually our usual solution. That's why I am not giving too much importance now. Okay, now I'll put a sketch. Where put a sketch here? Reactions are there. See, 1 minute here. Where to put the sketch? I'll forget these forces. Okay, I'll remember it. Okay, I will remember it. Or I can remove the question here. Better remove the question. Okay. Okay, I write here. Next step. I can copy and then rub it out. See. Last step now. Calculation of axial forces in all members. Little fast I am doing because this is repetition. Members by method of joint. Okay. Draw a neat sketch here. This all I can remove. This is not required. This is also not required. 6.428, I may forget it. I'll enter, then I'll remove it. Okay, see. Neat sketch. As neat as possible. Okay. How much? 3, another 3, another 3, another 3. Height is 5. This is 3. If this is 3, this is 3, little more, 5. Okay. Hope there is no space problem here. Okay, check it. Okay, now I'll check the camera. 1 minute. I'll move the camera if requirement is there. But put a little bigger hinge here. Okay. Then, these all hinges as usual. See, this vertical component here is, and horizontal component of the forces. How much it is? 7.660 kilonewton. This is the point A. Horizontal component is 6.428 kilonewton. And later, HA we got negative, it is left side. See, your HA equal to negative, left negative, 32.783. Last time 782 came, that 0.001, no problem. And vertical reaction we got VA, how much? 43.466. 466 kilonewton. Okay, camera if required, change. This angle is 40 degrees. Okay, then this angle is, I forgot the angle. See, what is that angle? I forgot it. Where to see the angle? It is 5.0346. 5.0346 divided by 3, shift tan inverse. Answer 59.210 degrees. Already calculated. 59.210 degrees. Okay, then this joint, see, these are all joints here. Joint. Okay. Vertical downward force of 19.151 kilonewton. Actually, earlier we had done a much more tougher question. Now, first of all, I should not tell anything. 16.070 kilonewton here. Here, vertical downward force of 12.257 kilonewton. This is 10.285 kilonewton. 285 kilonewton. Okay, then I can remove all this one now. Okay. Now I'll go for other one. This pin. There is a vertical load of how much? 30 kilonewtons here. There is a vertical load of 14 kilonewton. Load or force? Okay. Vertical force of 12 kilonewton. Vertical force of how much? 8 kilonewton. And here there is a reaction perpendicular to the plane of the roller. That is vertical reaction here, because roller is horizontal. VB equal to 59.602. 602 kilonewton. Okay, now this angle also 40 degrees. This also is 59.210 degrees. A, B, C. A, B, C, D, E, F, G, H. Okay, now I will give the answer for it. Now you solve. Now see. Now make a note here. Now it is same as old question. Already solved so many times. So this time you take exercise. At least do something. Start from joint A, then go to joint D, then go to joint F. After F, go to joint G. After G, come to joint B. After B, come to H. And then lastly, go to E. Those who want, check at C. See? Check at C. I will do one thing now. I will do super fast solution now. I have got a special calculator with me. You don't know. The special calculator. The special calculator is, it's an ultra special calculator. Okay, see. What you have to do is, that calculator, you have to show that calculator this frame. See? That frame. I request it. Please solve a method of joint. Okay, done. Okay, done. Solved. See? Super fast calculator. All values are in kilonewton, no space to write. This I only solved, remember, not copying. This is not copying. 32.635. Space is not there. 32.635 kilonewton. 47.302. 44.812. Actually, if I use calculator, I can do faster. This copying takes more time. I am not used to this copying. 12. 92.724. Point not one, not two, no problem. Enjoy the calculation. Actually, not you know it, everybody knows it. It is my other mobile. I took a photo of the last answer. That I wrote. See, it is not called copying. I only solved it. So why should I solve once again as if I have no other work? But you solve. You solve systematically and get the answer. Okay, this answer, hope. I think those who find difficulty for option 1, go for option 2. See, now we reach a stage where joint by joint, I will not waste time now. Now onwards, after maybe one or two special questions, otherwise it will be exercise for you. I will enter the answer here. Oh, one number missing here, see. Okay, one number missing. $51.219. Okay. Thank you. Go through it. Next class we will meet.